All right, and welcome everyone. This week we're going to be attempting to graph logarithms. So we will be using transformation rules to accomplish this. The first thing we're going to be paying attention is whether we have an h value or a k value. Your h value should always be inside parentheses with your x, and it should be part of the argument itself. This will shift your graph left or right, which obviously influences the x values of your graph. Your k is something added or subtracted that is not inside parentheses. It will shift your graph up or down, which affects your y values. Telling the difference between these is important not only to kind of tell which way your graph's going to move, but also to get your vertical asymptote. Logarithms always have vertical asymptotes, so going straight up and down. And it is x equals h. So if you see a number inside your parentheses, that is your h value. Just be careful. It's always going to be the opposite sign. So if you see a -2, you'd have a +2 as your vertical asymptote. Let's look at a few examples just to see how to get the asymptotes. So we can see this is our general form, log base of whatever, x minus h plus k. So like I said, our vertical asymptote is always x equals, and it is equal to your h value. Just be careful. It's always the opposite sign. So if you have a -3, your vertical asymptote would be +3, because really -3, the h in this formula would just be the 3. So similar idea for this next one, we have +5. So my asymptote would be -5. Just be careful on this last one. If you do not see parentheses, that means this is not an h value, that's a k value. So if you don't have an h value, your asymptote is 0. So if you don't see parentheses, it's going to be 0 for your asymptote. They don't always put it, but technically it's just the x in parentheses. Okay? So that's going to be our first step when we graph these. We'll always kind of figure out our asymptote. Then we're going to try and get a couple points. So how we're going to get a couple points is we're going to use the idea that exponential functions and logarithmic functions are inverses of each other. Like you can see, like y equals 2 to the x is the inverse of log base 2 of x, so on and so on from that picture. This will always be true. So the easiest way to do this is just take your log, take whatever the base is, put it up to x, use this to get a couple points. So like, for example, I would pick 0. 2 to the 0 power is 1. And then I would probably pick 1. 2 to the first power is 2. You want to pick small numbers. Always start with 0. And then this is the exponential form. So to get back to the log form, we're going to swap our x and y. So like, for example, that would be 1, 0, 2, 1, and then apply any rules you might have. And the rules are going to be based on what we have up here. Like, do you need to shift your graph left or right, up or down? Obviously, there's other transformation rules you could see, but for the purpose of this class and this week's assignment, you're just going to see horizontal translations or vertical translations. Let's jump into our first example. And this is from the Delta Math assignment I posted this week. You're going to see you have 6 questions. This is question 1. So I'm going to do 3 of the questions if you follow along with this video. See if you can try the other 3 on your own. But like I said, the first thing you always want to do is get your vertical asymptote. So like I said, if you have parentheses, it's the opposite of what you see because that formula has a -h in it. So we've got our asymptotes. You'll click that drop down on the computer. You'll see a line you can drag. Just drag it to the -7 on your graph. Okay, step 1 done. Now we just want to get a couple points. So like I said, you're going to change your log into exponential form. So it'd be your base up to x because we have a base of 5. Get a couple points. Like I said, I would always do 0 because that'll give you 1. And then if you do 1, it would give you 5. So to get our points on our log, we're going to do the inverse or just swap those points back around. And you might be tempted. This is, if there's anything I'm going to get across in this video, these are not the points that are actually part of your graph. We have to, that would just be if it didn't have anything like log base 5 of x, but we've got extra stuff in the original. We've got this +7 up here, right? So we have to do that transformation rule. If you look at your notes that I'm going to leave you or back at the beginning of the video, a +7 on the inside means you go left 7. So how I would do this is I would take those points we got in our blue table here, and I would go to them on my graph and don't plot them there, just go there and shift them left 7. So like for example, 1, 0 is actually one of the original points. I would just move it left 7. So I would go to -6, 0. And then my second point for my table was 5, 1. So if we go to 5, 1, it'd be here. We're just going to move it left 7. And you'll see like once you move those dots, it'll graph it in for you. That's your answer. Um, if you don't like doing the rules on your graph, one alternative is if you know your graph's going left 7, after you swap your X and Y's, you can just modify your table. Left 7 would just do all your X values -7. So just subtract 7 from those X values. So that would be -6. 1 -7, and then 5 -7 would be -2. And you would get those same points we just plotted. Okay, let's look at our second example. And this is problem 2 from the Delta Math assignment. So first thing, like I said, get your asymptote. For this one, since we don't have parentheses, we don't have an H value. That 4 is really a K value there. So our asymptote is going to be 0. So in this one, we also have a base of 5. So start with that exponential form. Honestly, I'm going to do the same points I just did. 0 power is going to give me 1. First power is going to give me 5. We're going to swap our X and Y around. Like I said, this would give you the log because we're kind of working backwards. We're starting with the inverse in a way. So swap those X and Y values. And then, like I said, don't plot these. I mean, those are going to be your starting points. We have to do the rules. So this one, we have a +4, or that means we're going to go up 4 since it's a K value. So I would just go to 1, 0 and go up 4. I would go to 5, 1 and go up 4. Sorry, I know this is a little sloppy, but you'd have 1, 4, and I'd have 5, 5 as my 2 points I just plotted. And then it would graph it in for you, and that's your answer. Like I said, if you prefer, you could do it algebraically. Like up 4 is going to really just move your Y values up 4. So you could just add 4 to your Y values after swapping the X and Ys, and those would be your new points you plot. All right, let's look at our final example. I'm skipping a little bit. I'm going to example 5 on the delta math. We're going to see we have an H and a K value for these last two. So get your vertical asymptote. So this one, it's the opposite of what you have or what your H value is, -2. Go ahead and plot that. Now we're ready to kind of get our couple points. So our base is 3 in this problem, so a little bit different. Like I said, always do 0. That's always going to give you 1. But if I did 1 for this, 3 to the first power is 3. So then we're going to swap our X and Ys. And like I said, don't plot these points. Those are going to be your starting points. We have to do the rules that our original function gave us, right? So just if you look, this +2 means to go left 2. And this +3 on the outside, or that K value, means to go up 3. So we've got 2 rules in this one. We're going to go left 3, left 2, and up 3. So if you just want to do the starting point, go to 1, 0, and go left 2. That would take me to -1 and up 3. I don't know if that's really showing that well. But if you went to 1, 0 and went left 2, up 3, you'd be here. If you started at 3, 1, go left 2, up 3, you'd be here. And that would be your graph. Just to show you, if you prefer to do it algebraically, you can. Left 2 would take 2 off all your X values. Up 3 would add 3 to your Y values. So if you did those rules, these are the points that I just plotted. You would do 1 minus 2 is -1. 0 plus 3 would be 3. That would be my first point. Then my second point, subtract 3 from my x. That would be 3 minus 1 is 1. Oh, sorry, I said that wrong. 3 minus 2 would be 1. And then 1 plus 3 would be 4. And those were the same points I got when I did the rules on my graph, but either way is acceptable. Hopefully, this helped a little bit. See if you can get this delta math done. I am planning on putting this on fourth quarter, so if you can't get it figured out this week or you got other things going on, it hopefully gives you a little more time. But have a good one.